as he said, my name is Paul Pearce, and I'm going to be talking to you about global measurement of DNS manipulation. This is joint work between the University of California, Berkeley, Princeton University, and the International Computer Science Institute. Some aspects of internet censorship are very well studied. Many of us are quite familiar with the Great Firewall of China, which performs censorship of content that the government of China deems objectionable in some way. Similarly, when a large country censors a well-known internet service, that will make headline news and draw researchers' attention to the problem, such as what happened with Turkey and Wikipedia earlier this year. But unfortunately, the problem of internet censorship is not just confined to a handful of countries and a handful of well-known internet services. Recent work has shown as much as 2/3 of all internet users are subject to some form of government-sponsored internet censorship. And being able to empirically find, measure, and understand this global censorship censorship remains an open problem. And one reason this remains an open problem is despite the prevalence of censorship, empirical measurement remains relatively sparse. And it remains sparse in a number of ways. For example, it could be sparse across time. A study may focus on the state of Chinese censorship in August of 2017. It can also be sparse across space. It may focus on one or two countries or a particular region, or maybe just one or two vantage points within each of those countries or regions. And these empirical measurements can also be sparse across content, meaning they may focus on censorship of particular types of content, social media platforms, search engines, things of that nature. And the reason for this is the deployed state of the art really very much relies on volunteers. Researchers need someone in the country to perform some measurement on their behalf or to host a machine that enables them to perform some type of measurement. And what we're going to argue here today is continuous diverse measurement is needed in order to properly understand the scale, scope, and evolution of internet censorship. And this brings us to our work. The space of internet censorship is quite large, and there's many different facets that have been studied in a variety of different ways. Today we're going to be focusing on DNS manipulation, meaning we're looking at governments that are manipulating DNS responses in order to censor content. And as we perform this work and as we give this talk, we're going to have a number of very specific measurement goals in mind. Specifically, we're going to try to do measurements that are going to be diverse, meaning we want to measure from multiple different countries, multiple different geographic regions, and also, more importantly, from multiple vantage points within each of those countries. We also want our work to be able to be longitudinal, meaning that we can perform these measurements repeatably over time with reasonable overhead. We don't have to go out and recreate an entire new measurement system and find whole new vantage points every time we want to ask a question. Secondly, we want to ensure that whatever system we build does not require user participation, as this will fundamentally limit the scale of our system if we have to go out and find a volunteer in every country and every network every time we want to do any type of measurement. And lastly, we need our measurements to be ethical. We do not wish to harm users or subject users to some sort of harm as part of our measurement work. And to this end, we will design, implement, and deploy IRIS, which I'll be talking to you about today, a system to identify DNS manipulation globally. And we'll conclude the talk today with a global measurement study that focuses on really identifying the prevalence of censorship worldwide, with a particular focus on the heterogeneity of content, countries, and particularly with the heterogeneity of censorship within countries themselves. So how are we going to do this work? This is conceptually quite simple. If you want to do a global DNS measurement study, perform DNS resolutions from around the world. It doesn't sound that hard. And then once you do all of the resolutions, you're going to get all of your responses, you're going to take the wrong ones, you're going to make some graphs. Conceptually really straightforward, but you're going to run into a number of challenges, which we're going to talk about now. The first challenge is how do you get a number of vantage points all around the globe? And the way we're going to address that challenge is through the use of open DNS resolvers. And then I will now quickly put up the second bullet, which is the moment I say we're going to use open DNS resolvers, this immediately raises a question of ethics. Prior work has shown that open DNS resolvers are by and large home routers, users. If you perform measurements against them, you will cause harm. So we're going to, in our work, take efforts to identify infrastructure DNS resolvers. So these are resolvers that are not users that we can leverage to perform our measurements safely and ethically. The next challenge is how do you build a system that can be run repeatably? And that'll come into how we actually designed and built our system IRIS. We'll talk about that throughout the talk. And lastly, the final challenge is how do you actually identify a wrong DNS response? This turns out to be problematic in and of itself, and to give you a little bit of insight, which we'll touch on much more later, we're going to rely on consistency and independent verifiability. First and foremost, before we get into the system and the measurement, I want to talk a little about ethics. All of our work and this system is guided by a number of ideals, and these are particularly the ideals laid out in the Menlo report. There's a few of them. The first is going to be respect for persons. We don't want to force a user into performing a measurement they did not consent to or they do not wish to perform. The second is beneficence, Meaning for every particular measurement we're going to perform, we are weighing the potential good of that measurement versus the potential harm. We're not going to resolve every single thing on the internet, because that has very small additive gains versus resolving small sets of things that are representative of particular categories. Lastly, we're focused on respect for law and the public. We do not want to entice or force users into breaking the law. We do not want to overwhelm internet services through large number of queries, things of that nature. To that end, specifically, we're only going to use resolvers that are reasonably attributed to internet naming infrastructure, and we'll talk about that in the next slide, exactly how we do that. And secondly, we're going to heavily rate limit queries to both resolvers and domains to ensure that we're not beating up resolvers, we're not beating up domains. Okay. So how does this work? Let's start talking about systems. This is all going to begin with an internet scan. So we're going to perform a scan of the IPv4 address space using extensions to the ZMAP project that we authored that are going to, for every IPv4 address, perform a resolution for a domain that we control which is not sensitive. And because we know we control this domain and it's not sensitive, we know exactly what the right answer should be. So we can filter down to DNS resolvers that are only returning correct answers. So once you have the complete set of open DNS resolvers, we can use another tool that we helped author called ZDNS to perform PTR lookups of all of the open resolvers on the internet. And what we're doing here is we're trying to get naming information associated with these open resolvers. Because ultimately what we're going to do is we're going to filter all of our resolvers down to things that report to be name servers. These are things that are nameserver.example.com, ns1.example.com, and so on. And we're going to confine all of our measurements to these open resolvers that are associated with internet naming infrastructure. So we talked a little bit about how to measure, but what are we actually going to measure? And so we're going to measure a variety of domains that fall into two categories. The first category is going to be sensitive domains. So in order to identify a list of sensitive domains, we're going to rely on a civil society organization called Citizen Lab that has compiled a list of URLs which are known to be censored and sensitive across various countries on the internet. We're going to take all those URLs, we're going to distill them down to domains, and we're going to resolve all of them. Secondly, we're going to look at a set of popular domains. So we're going to randomly sample from the Alexa top 10,000, and we're going to take those domains and also resolve those. We're then going to take these artifacts and we're going to feed them into our system iris, and the ultimate output of this system is going to be responses that are identified as manipulated or non-manipulated. And so we talked a little bit about iris. Now on this slide, I'm going to sort of push through exactly how the system works in a variety of stages. So the first input to our data set to our system is going to be both the set of both infrastructure and sensitive and popular domains. We're going to feed this into another tool we built, which we're calling a DNS scanner, that is going to simultaneously resolve all of these sensitive and popular domains against each of these infrastructure resolvers. And it's going to do so while carefully enforcing rate limits to ensure we're not stressing one resolver or one domain too much. And at this point, we're done, in theory. If we had a magic oracle that could take a particular DNS response and say, is this response manipulated, this problem would be solved. But there's a lot of white space on the right side of the slide, so we probably have more work we're going to have to do. So the next step we're going to do is we're going to take all of these DNS resolutions, and a DNS resolution has an IP address. Hey, what's the IP for example.com? Here's an IP address. So we're going to take that IP address, and we're going to start looking up information about it. We're going to start annotating it. So we're going to go off to like the census data set, and we're going to say, what AS is this IP? What HTTP content existed this IP? What is the HTTPS information about this IP? We're going to go to Maximind, and we're going to collect geolocation information. And we're going to use this later on in the process to be able to separate our DNS resolutions into two buckets. The next thing we're going to do is active secondary scanning. For each of these IP addresses, we're going to get the PTR record associated with it. That helps us, is it part of it? What AS is it? Is it part of a CDN? Things like that. We're also going to reach out and connect to it and say, hey, what is the certificate for example.com? And collect that information. And then we're going to take all of that information and use this to solve challenge number 4, which is how do we actually identify wrong responses? I'm going to go through this in some depth now. So the intuition behind this is going to be, even in large global deployments of services, there's going to be some shared structural elements associated with those domain names. And that can take a variety of different forms. And as I said, we're going to rely on this idea of consistency and independent verifiability. But what do I mean when I say that? So when I say consistency, what we're going to do is we're going to have a set of controls. And these are resolvers that are around in a number of countries around the world that we personally run. We used 4 for this particular experiment. And these are going to be resolvers that are not manipulated. They're in countries that don't experience pervasive DNS manipulation. And we're going to perform all these resolutions. And then when we get a particular response we want to be able to classify, we're going to ask whether or not it has any shared elements with this control resolution. That can be, it's the same IP address. Is it in the same AS? Is it from the same CDN? And if any of those are the same, we're going to say, all right, this looks correct. And I'm going to talk a little bit about limitations with this in a moment. Separately from this, we want to understand whether or not we can independently verify whether or not a particular response is correct. And in order to do that, we're going to say, hey, if we connect to this IP address, and we think it's google.com, and it presents us a valid browser trusted certificate for google.com and can prove that it can use that certificate, that is independently verifiable correct. We're going to consider that to be a correct DNS response. And then if any of these metrics are either consistent or independently verifiable, we're going to call the response correct. And this absolutely has limitations. Active adversaries can absolutely game this easily. But we're not particularly focused on that here. We're trying to provide a lower bound to get a handle on what is the pervasive, obvious form of DNS censorship we currently see on the internet. Subtle forms of censorship can absolutely still occur, but that's a little bit outside of scope for what we're trying to do today. All right. Turning back to our pipeline, once we have all these DNS responses, and we essentially then will bucket them into two buckets, the correct answers and the incorrect answers. And that's sort of the end of our system discussion. And at this point, I want to sort of change gears pretty dramatically and start talking about what we found when we used this system and deployed it in a real-world scenario. So for this part of the talk, I'm going to talk about the data set associated with this work. And then I'm going to change gears and present some measurements associated with that, and then I'll conclude. And so as we start talking about the measurement study, there's some questions you might be interested in and want to ask. And the first question is, what is the population of open DNS resolvers on the internet? What does it look like across a geographic distribution? How many are there? And so from using the metrics we outlined earlier, which is, did it correctly resolve this control domain that we own, we found 4.2 million open, correctly functional IPv4 resolvers on the internet. Those 4.2 million resolvers were spread across 232 countries, with a median number of resolvers per country of about 660. And so a very obvious second question is, we're limiting this data set to things that are naming infrastructure. How much does that reduce our coverage? And the answer is quite dramatically. So by employing this ethical framework of saying we only want to use infrastructure resolvers, this takes us from 4.2 million resolvers to only approximately 6,500. But luckily, those 6,500 are spread across still 157 countries and dependent territories. But the median number of resolvers per country is down to only 6. That number 6 is slightly misleading, and it comes from a very long tail of countries with very small internet deployments. And as you'll see in subsequent slides, for most countries we're going to talk about, there are far more than 6 resolvers in those countries. So what is the total set of DNS queries that we're going to talk about for this talk? Across these 6,500 resolvers, we then performed resolutions for 2,300 sensitive and popular domains, which, when you multiply that out, gives you 14.5 million DNS resolutions, which were ultimately going to bucket into correct and incorrect categories. So these are the sort of vital statistics for the data set, but it doesn't tell us anything particularly interesting about what we found. So let's start talking about what we found when we actually ran this system. And I want to start talking about manipulation by country. So we're going to aggregate all of our results based on geo-IP information associated with each of these open resolvers. And so the first question is, all right, what countries experience the most manipulation? And I'm going to present this table on the right side of the screen, and we're going to walk through it very briefly. And the way we're going to sort of bucket a country by what experienced the most manipulation is by median resolver within that country. So specifically what I mean is, for each resolver in that country, we're going to perform a bunch of DNS resolutions. We're going to see what resolutions are wrong, and then we're going to take the median number within that country. So the median resolver in Iran had 6% of sensitive and popular domains come back as manipulated by our system. China had approximately 5.2%. And this is qualitatively consistent with prior work that have showed that these countries have some amount of DNS censorship, and the content is roughly similar as we've seen in previous work as well. And so another question you might ask here is, earlier in the talk we stressed the need for heterogeneity within countries. Is the median representative? Are there outliers that censor either more or less within those countries? And the answer is going to be yes. And so we revealed another column that for each country said what resolver in that country manipulated the most number of DNS responses. And for every single country on this list, there was a resolver that manipulated more than the median, in some cases significantly more. And what this points to is essentially localized manipulation. So there are networks within these countries, corporate networks, university systems that have opted into additional DNS manipulation to do things like filter out pornography, things of that nature. And if you have vantage points only within those networks, you're going to have inflated senses of censorship when you perform your studies. Similarly, there's a question you could ask is whether or not there's outliers on the low side. And the answer here is actually quite shockingly yes. For every single country we measured, we had a resolver that geolocated within that country that saw no DNS manipulation. And for manual investigation, this is geolocation error. So there are resolvers that we thought were within China, thought we were in Iran, that were in fact not within those countries. I want to change gears again, and I want to talk to you a little bit about manipulation by domain. Rather than aggregate by country, what happens if we start looking at the individual domains that are experiencing DNS manipulation? So what domains are manipulated most frequently? And we're going to rank that by the number of countries in which we see manipulation for each of these domains. And we're going to explore this with the table on the right side of the screen. So we have here the top 10 domains ranked by country, and the categories associated with each of those domains. And from this, what we find is gambling and pornography are dominating the top 10 domains. 8 out of the top 10 domains fall into these two categories. And so an immediate second question which you might want to ask here is, are commonly measured sites, are these also frequent targets of DNS manipulation? So for example, frequently we will see measurement studies that focus on search engines or social media sites or even anonymity tools themselves. And what we find is no, they experience significantly less manipulation globally than some other sites and some other categories. And so I put that on the bottom of the screen here. So none of these very popular measured services are even in the top 100 of domains that experience the most manipulation. Tor is the only one that at rank 80. And what this really points to is a need for diversity in the domains that we measure in our measurement studies. Rather than focusing on things that we all think are censored very broadly, Facebook, Twitter, Tor, we need to focus on more domains that spread a far more diverse set of categories. And speaking of categories, what happens if we, instead of aggregating by domain, we instead aggregate by category? What do we find? So what categories are the most frequently manipulated? And I'm posting this on the screen here on the right side. And quite surprisingly, is the category that experienced the most manipulation globally was actually the Alexa Top 10,000, a random subset of the Alexa Top 10,000. And what this points to is there's a lot of things out there that are not immediately known to be sensitive. They're not on some of these lists of sensitive websites that are actually still being manipulated in a variety of countries worldwide. And also worth pointing out is if you go back to the prior slide, and 8 of the 10 most manipulated websites were gambling and pornography. But if you look at categories, they are not the most manipulated categories at all. This has to do with the composition of these categories. Not all categories are created equal. The population of these categories are not equal as well. And if we go back to the question from the prior slide as well, and we ask the question, what commonly measured sites are commonly measured sites the most frequent targets, the answer here is going to be no as well. So if we go through all of Google's properties, so this is stuff you don't even think about, Blogspot, things of that nature, all of Facebook's properties, all of Twitter's properties, and aggregate them all together, they are still not the most popular, most frequently manipulated categories from a DNS perspective. I want to talk about one last set of measurements, and we're going to spend a little bit of time on this because there's a lot of depth here. And I want to talk about consistency within countries. Like, depending on where you are within various networks and within various locations within countries, does the story of DNS manipulation look the same? So we're going to ask the question, is there heterogeneity within countries? And the way we're going to explore this is with a scatter plot broken down per country. And what we're going to do here is for each country, we're going to have sort of a different column. And then each mark on this graph is going to be a different domain. So we're going to take, for example, let's say google.com. We're going to say, all right, Google, what percentage of resolvers within Iran in some way manipulated you? And if the answer is 1, we're going to put a mark at the very top of the screen. And if the answer is like none of them, we're going to put a mark at the bottom of the screen. So what you're going to see is essentially, depending on how similar censorship is, you should start to see clusters of clusters of points on this graph. And so now that we've sort of explained how this graph works, and excuse me, we're going to have a density plot overlaid behind it to sort of de-alias points that fall on top of each other. And so now, once you sort of walk through this, let's reveal the rest of the graph. And so here are the top set of countries that all experience DNS manipulation. And to answer the question, is there heterogeneity within countries? The answer is very strikingly yes. And rather than taking in every bit of this graph, I'm going to walk you through a number of features associated with it that we think are particularly interesting, and we'll leave the rest of the discussion of the graph for the paper. And so is there heterogeneity? Absolutely. And the first thing we want to call out are these modal effects within certain countries. So let's focus first on Iran. So in Iran, there's a set of there's a set of domains that are manipulated by about 80% of resolvers within the country of Iran. But there's a completely separate set of domains, the circle at the bottom of the screen, that are manipulated by a very small set of resolvers within the country of Iran. And depending on the country and depending on the exact scenario, this points to one of two effects. This either points to multiple federated systems that perform different type of censorship depending on the content, or it points to localized manipulation. There are vantage points within various countries that have different levels of censorship or block completely different things. The second question we can answer from a plot like this is whether or not we observe non-determinism in DNS manipulation. And the answer here is yes. Again, let's look again at China. And we see this interesting smearing effect. And what this indicates is essentially, rather than censorship being crisp, is Google always blocked? Well, it's blocked most of the time, for example. And this comes from race conditions, and this is qualitatively consistent with prior work as well, from prior work that is built upon the notion of actually putting vantage points within those countries. Right. Excuse me. Another question we can answer from here is whether or not we see ISP level filtering. So rather than government mandated firewalls at the border of a country, do we see manipulation that is being pushed down to the ISP level? And the answer here is yes as well. We're calling these low but incomplete countries. For example, if a country has a small set of resolvers that are very consistently censoring a large swath of content, this generally indicates that ISPs, for example, residential ISPs, are performing manipulation as opposed to there being some government mandated system. And a result of that is going to be, if we attempt to find vantage points within that country and we just happen to not be in the network, we will not see the same type of DNS manipulation that we will see in other parts of that country. And the last thing I want to talk about is geolocation error. And I touched on this earlier, but it really jumps out at you in a plot such as this. And is there geolocation error? The answer is yes, absolutely. And we see this in what we're calling high but incomplete countries. And I want to walk through China for a moment. So in the case of China, no domain in our data set was manipulated across more than about 85% of resolvers. And that's a very odd result. And when we looked at this result and with manual analysis, what's happening here is 15% of the resolvers we thought were in China are not in China. They're generally nearby. They're in Hong Kong or other countries nearby that are not even transiting through China and are not experiencing any type of DNS manipulation. This really points to the need for good geolocation services and methods that understand that geolocation is a prevalent problem and really treat this as a first-class issue that needs to be resolved. All right. I sort of at this point want to take a step back, and instead of presenting results, I want to talk to you a little bit about some methodological takeaways. So how should you think about performing measurement studies of this kind? What did we learn? How should you approach the problem? And the first is that domain selection is absolutely critical for comparative studies. Any biases in the list of what you measure are absolutely going to influence any type of ranking or comparisons. Like if you have a list that is dominated by content that is manipulated or censored within China and Iran are going to be the countries that show the most manipulation. And there's a real need here for understanding how these various sources of sensitive content are constructed and to really understand the bias associated with those lists. The second is measurement of non-sensitive content is important. These lists are created by people. The time constants there are large. It's hard to keep them up to date, and by their very nature, they will always be incomplete. So sampling of other popular sites will find you additional content that you do not previously realize was sensitive. The next bit is how you group the data is going to influence your results. If we wrote a measurement paper that said, here's the top countries, we're going to get one story. If you write a measurement paper that says, here's the top domains, that gave us another story. That gave us the story that pornography and gambling was really where all the censorship was. But if we write a paper that says, all right, well, we looked at categories, that's going to tell us, well, hey, freedom of expression and peer-to-peer file sharing is really where the censorship is. And so there's no right answer here. You really need to do a variety of different comparisons and a variety of different aggregations to really understand the full story of internet censorship globally. And lastly, in-country diversity is absolutely needed to accurately depict manipulation. If you you go out to buy a cloud service provider in a country, that is going to give you a different story of DNS manipulation than if you have a machine in a residential network. And this comes not only from these outliers high and low, but also because we know there are federated systems within countries that perform differently. All right. At this point, I'd like to conclude and talk briefly about our next steps. Hopefully, I've convinced you that internet censorship is prevalent and heterogeneous. I talked about IRIS, an ethical system to identify DNS manipulation internet-wide. We talked about the heterogeneity of censorship across multiple different dimensions, hopefully highlighting the need for tools such as IRIS. And lastly, where we're going from here is we're using Iris and other work out of our group to really run these systems continuous to really try to understand what these trends look like longitudinally. And I would like to thank you for your time and open the floor for questions.
Albus Reduce Google. So did you look at what is being done with the DNS manipulation? Is it consistently censorship, or is it, say, content injection or transparent proxying or stuff of that nature?
It varies pretty wildly. We go into more depth. We quantify the types of responses we get. Are they non-routable IPs? Are they routable IPs? We don't actually look at the content, but we do drill into this a little bit more in the paper. Yeah.
Abdul from Carleton University. So have you tried using the eDNS or the extension DNS that passes also information about the source IP address who's asking and checking if censorship techniques take that into consideration as well?
It's a great question. We haven't actually done that. We do talk about this, and this is, you could imagine a system that only censors if the client connecting comes from that country. Absolutely right. This is something we're aware of. We haven't quantified that.
Hi, Daniel Sokolow from Heze. I was wondering why you didn't use the Atlas network.
So I have some familiarity with that system. I don't have a ton. My understanding is that it's primarily, I would like to have a further conversation about that. My read there is that the types of networks associated with that will not have the same diversity that we were hoping to achieve with a system such as this.
Hi, Matt Van Gundy from Cisco. Mm-hmm. Your discovery that the Alexa Top 10,000 was blocked more often than pornography websites sounds surprising. Was that like the rate or the percentage of the items on it? So it wasn't just the number of resolvers.
So this is a good question. And this is going to come, none of these categories are created equal. Like some of them will have far more domains in them than other categories. And some of that absolutely does come from that. The fact that the Alexa category is larger than some of the other categories we see.
So was it a ranking by the percentage of the
It was a
category
ranking, I believe that graph was particularly a ranking by, it was not by percentage, it was by raw number of countries that experienced manipulations of things from that category.
Okay, so you would expect larger categories to be at the top.
Yeah.
Okay.
That's not always the case, but that was the case for Alexa.
Okay.
Yeah.
Hey, Martin Grote from University of Roya. I would like to know, you used like 6,000 open resolvers instead of the whole resolvers. Can you comment on how this would influence your outcomes? So I would expect that there could be much more difference between the outcome you have when you would look at all of them.
That's a great question. I would say to start to get a handle on that, you could look at some prior work that has looked at larger populations of resolvers without sort of applying any sort of ethical framework to that. I don't know how those outcomes would change because by the very nature, we're not comfortable performing DNS queries against all of those resolvers. I think there's some work we could talk about to say just how would you start thinking about that, but I don't have a great answer for you.
Okay, thanks.
If you want to go ahead and start setting up, just one more question for Paul.
Mm-hmm.
Thanks, great talk. Quick question for you. You talked about the Alexa Top 10,000, and you used, I think it was something like 2,300 domains from that. How did you said picked randomly? I mean, can you tell us a little bit more about the selection process?
We go into this in more depth in the paper. We started with the list from Citizen Lab, and we condensed that down to unique domains. And then we said, all right, how large is that set? And then we matched the same set from Alexa. So we randomly sampled from the Alexa Top 10,000 and said we want to have roughly a 50-50 split between sensitive domains and non-sensitive domains so that we could get a sense of how manipulation is sort of biased towards or away from those categories.
Let's thank our speaker one more time.